Today we're going to go through a simple Hello World example that's going to help us understand serverless. And then we're going to talk about what serverless means and then some of its benefits. And then at the end of the talk, we're going to go to my favorite place, which is Serverless Land. It's a website that my team runs, and there's just so much content in there to learn more about any of the AWS serverless services. All right, so do you all remember when you first started to learn programming? One of the most common first lines of code that any new programmer writes is hello world. And a lot of times it's just printing it out, right? And you can write this in any language. But what does it look like as an application? Let's take a look. If you wanted to run a web server version of hello world, this is what it would look like, right? You have a Node or Express server, and then in the stack, you have the actual server instance, you have the operating system, you have the runtime, you have the web server, and all of these need patching, maintaining, feeding, watering. But when you look at the code, the business logic is only one line, right? And the rest is just overhead. Now, let's say you want to run this in production. So now this is what our Hello World application looks like at scale. You need multiple servers for availability in different geographical areas. You have a security group configuration and VPCs. You probably need an image of the stack so you can deploy more servers. So I have to manage an image now. But then what if you need more than 3 servers or less than 3 servers? So now you have to think about all of these other dependencies and all of these other things, but I just want to run this one line of code. The serverless approach helps developers focus back on the actual code that they care about. And so if you look at this application, this Hello World application, how it would work as a serverless app, this is kind of how you do it serverlessly. You have one Lambda function containing your one line of code, and then you put an API gateway endpoint in front of it. And so this example is massively scalable right out of the box because API Gateway and Lambda scale automatically. It's highly available out of the box because if your function uses the default network environment, it automatically becomes available to execute with all of the availability zones in that AWS region. So nothing else is required to configure high availability. It's also super secure because it can only be called by this endpoint that has granular permissions with IAM, which is AWS Identity and Access Management. So this is the key to why serverless is different. You focus on your business logic and not the machinery underneath it. It's all about simplicity. So serverless can make things very simple. And as an example, I want to focus on web applications since I know many of us here today write this kind of application. And so this could be a LAMP stack or any other typical web app stack. And so when you consider vertical scaling, horizontal scaling, load balancing, availability, security, maintenance, monitoring, and then not to mention the actual features that you should be writing in your app too, very quickly in production, you're going to end up with architecture that looks like this. And so what this is a best practices reference architecture for WordPress on AWS, but this could easily apply to any traditional web app on a server. And so what is important to understand here is that most of what's here handles scaling, availability, and the machinery of running the app. And it's really hard to manage this without a full DevOps staff and continuous management and monitoring. And at scale in production, server-bound technology explodes in complexity. And so let's just compare this to a serverless approach. In this approach, users hit an API endpoint that can trigger a Lambda function and write to a DynamoDB table. Everything in this diagram is related to the actual architecture of the app, not the mechanics. And so the benefits of this architecture are that you get global scale via the content delivery network. The application is automatically load balanced, so all of your app resources get downloaded by a global CDN, and we're interacting with an auto-scaled API gateway endpoint. It's all much, much simpler with serverless. So hopefully you have some context here. Let's get into serverless a little bit more. So when we say serverless, we mean it's the removal of server operations. And this is a really important distinction for customers because it allows you to focus on the building of the application and your business logic rather than the management and scaling of the infrastructure to support the application. And there's 4 tenets that define serverless as an operational model. The first one is that there's no infrastructure to provision or manage, so there's no servers to spin up or operate or patch. Serverless applications automatically scale by unit of consumption rather than by server unit. So automatic scaling is a really big win for companies because generally you create multiple MVPs and you don't want to have to build all of them out for scalability. Serverless also has a pay-for-value billing model, which means you only pay for what you use, not idle time. So if you have an idea that's not taking off, it can get expensive if you're paying for all of that time. What this means is that you can experiment more. So let's say I have an idea for a new feature and Eric has a competing idea for a new feature. Eric and I can A/B test our features, and regardless of which feature has a higher conversion rate, it's not going to cost you much because you're only paying for what your customers are using. And lastly, serverless applications have built-in availability and fault tolerance, so there's no need to architect for availability because it's built into the service. And this is really important because, things will happen, unexpected things happen. There's outages, there's earthquakes, spaghetti and meatballs can fall from the sky. So what do you do if the servers handling your project fall over? How do you know that all of your versions are in sync with all of the regions? Have no fear, serverless is here, my friends. This all happens automatically. Serverless applications have built-in availability and fault tolerance. You also get greater agility, which we're going to talk about a little bit later. You focus less on operations and more on your product, so you don't have to architect for scaling and availability. Serverless does that for you. And this also leads to a faster time to market. There's also a lot of ways to scale, and not every app really needs to scale, but this is useful because when you think about serverless applications, one of the common challenges that I've found in the various development teams that I've been on is around gathering requirements. So when do you know what to build? Is this, are you in an enterprise using waterfall when you know all of your requirements up front? Or at the end? Or do you discover requirements along the way? You might also find requirements changing frequently and there's no clear end to the project. So a lot of times when you're building applications, it's really common to find changing requirements. And this is because customer needs change more quickly. We're really in a really fast changing technical world right now, and customer needs are adapting and changing really quickly, and we have to adapt and change with them. Product teams are moving towards iterative development. This also means you have shorter delivery cycles and your customers want new features faster. In a traditional way of developing apps, often decisions are made early, and that can create a lot of inflexibility as your application development evolves. And that's very hard to architecture at the beginning because at the beginning is when the requirements are usually less understood. And so serverless helps with agility. How does it do that? Firstly, you have less code. It's typical to find serverless projects that can be 50 to 70% lighter. And this is because you have less code for authorization, for database connections and management. You don't have to architect for scalar availability. There's no infrastructure management. You really only focus on your business logic, which is a lot less code than your entire application, right? Microservices are more agile. So monolithic applications are much more fragile. A lot of times if you break one thing, you break everything, right? So with microservices, it's easy to split up and work into teams. You have services for common tasks. So a lot of your repetitive tasks like auth, database handling, session management can be handled with the different AWS services. And we're going to be talking about the different services in a minute. These can also be baked into the platform. So monitoring, logging, tracing, a lot of that is built into these serverless applications that you use. For example, when you use Lambda, it's integrated with CloudWatch logs so that everything that your Lambda function does is logged automatically for you. Serverless also helps with CI/CD, versioning, and automation. And one way it does that is with infrastructure as code using CloudFormation and SAM. SAM is the serverless application model, and it's an open source framework for building serverless applications. And so when you use infrastructure as code, you can use SAM templates to deploy resources to specified environments. And this type of automation is what helps minimize environment differences. With serverless, you can make changes faster and more reliably. At the center of serverless is a service called AWS Lambda. It's a serverless product that's the core of a few terms: event-driven computing, functions as a service, and it's serverless, which means it meets our 4 qualifiers that we talked about. AWS Lambda lets you run code without provisioning or managing servers. You only pay for the compute time that you consume, so there's no charge when your code is not running. With Lambda, you can run code for virtually any type of application or backend service, all with zero administration. All you have to do is upload your business logic, upload that code to Lambda, and Lambda takes care of everything required to run your code and scale your code with high availability. But Lambda doesn't just sit in a vacuum by itself. It's one of the parts of a serverless application. And now typically with Lambda functions, there's 3 different parts. You have the event source, the Lambda function, and then the service or the destination. And so the event source has a number of services that can directly interact with Lambda. An event, that event can be almost anything. So it can be an HTTP call, a cron job, something uploaded to an S3 bucket, maybe a payment arriving through Stripe, through a third party, or it can be an event coming from another AWS service. So the event is something that happens that causes a Lambda function to come to life. And then you have the Lambda function, which provides curated execution environments with various languages built in. We also have a runtime API, so you can basically bring any language into Lambda. And then you have the destination, and that can be whatever your code needs to interface with. So this is entirely up to you. It just depends on your business logic and requirements. Lambda can interact with almost anything in AWS or externally. And so in this context, when you think about it like this, a Lambda function acts more like glue, right? It's a mechanism for processing data between different services. So an example of what this might look like for an e-commerce application is that when a customer pays for something, the payment gets processed, and then now they have access to the service. So you have an event source that is the customer paying for something through maybe Stripe, and then you have the Lambda function that processes the payment, and then you have access to whatever service you need to. Lambda can interact between services like API Gateway and DynamoDB. Just by itself, this is now an API for a CRUD application. This API is massively scalable and has high throughput, and the Lambda function has very little code because remember, it only contains our business logic. And you can just as easily have it store durable objects in a service like S3. You can also serve globally over a fast CDN like CloudFront, and maybe you have the images in the S3 bucket analyzed by recognition and then store the results back into the database. The database can also trigger another Lambda function, which sends an email or sends messages to a queue. And then as you start to build with these different services, you write less code, right? You create a resilient distributed infrastructure and you create clearer architectural maps. And this is really great for onboarding too. When you onboard new engineers, you don't have this huge complex architecture diagram of like, this is how our app works. You have simple services that work together to make your application come to life. And so in this way, you have more capabilities to your applications. And so again, you do all of this without worrying about patching, versioning, watering your servers. You also don't need to worry about operational overhead or scaling or architecting for availability. So I mentioned Lambda can connect with almost anything in AWS, which means full access to the power of machine learning tools like SageMaker and Comprehend. You can also interact with IoT tools like IoT Core, analytics tools like Athena and Kinesis, media processing tools, and web, mobile, and digital service tools. So now we know what serverless is and we know where Lambda fits in, but how do we know how to use these tools and what are the best practices? Some of the most common serverless application types we see are web applications. And these are things like static sites, complex web apps, single page applications. We also see serverless backends. We see serverless data processing and analysis. We see serverless chatbots. We see serverless applications using Amazon Alexa for voice-powered apps. And then we also see IT automation, so things like policy engines, extending cloud services, things like that. Okay, let's talk about some best practices with serverless applications. So the first one is to avoid lift and shift. So transferring a server app to a Lambda function doesn't give you all of the benefits of serverless. So this really isn't a best practice. What you want to do is focus on the application flow and integrating with serverless services. You also want to focus on events. So remember that events trigger serverless workflows, and an event, like we talked about, is just something that happened. So think about like an object is uploaded to an S3 bucket, or an item is updated in a DynamoDB table, or a payment is processed by either a third party, or a payment is processed in your app. So just think of it as like, this is something that happened. Your functions are ephemeral and stateless and only come to life in response to an event. You want to keep your functions small. So a function might only be 20 to 100 lines of code. And when you're writing code like this, you want to make sure that your Lambda functions each do one thing. So if they're doing a few different things, a lot of times it's a good idea to break them down into smaller pieces, because very large functions can get a little bit complex. So it's a good idea to break them down into smaller pieces. You also want to try to avoid monolithic functions. In terms of runtimes, you want to choose the right runtime for your job, but remember that you're not limited to a single runtime as with most traditional applications. So you could have your backend in one language and your front end in a different language, whatever works for you, for your application. Treat your code like plumbing. So your code should be stateless and it should be connecting services. It should be like the pipes connecting different things in your plumbing, right? You want to find the right place to start. So start in the right place for your organization, see the value, develop more skills. So just remember that while not all applications should be serverless, some part of all applications can be serverless. This revolutionizes how you can develop scalable applications quickly. And I use the word carefully and deliberately because serverless is not an incremental change in the way you develop things. It's a revolution. It radically and fundamentally changes the way developers work. Remember, you don't think about infrastructure management and servers and availability and scalability. You only think about your business logic, and that's why it's so revolutionary. It comes down to 4 fundamental factors. The first is agility. So how fast a piece of software can change to meet new needs. And think about this. Right now we're in this explosion of mobile applications and customer interest in technology. And serverless can help you accelerate this. Again, with serverless, you have less code. Your apps are basically a group of Lambda functions and services, and everything is lightweight and easily changeable. So if you want to make changes anywhere in the process, you can. You don't have to wait until specific parts are completed. You can really make changes to your application at any time. Some applications in the world now have tens of millions of users, and this scale creates uniquely hard problems to solve that emerge from vast engineering complexity. Scaling is a really hard and expensive problem, and companies face unpredictable workloads and what's called spiky traffic. So, for example, if you have a company that you run a TV ad and you get slammed with traffic after you run that ad, and what happens if you can't scale in time because instant scaling is not immediate? So even seasoned DevOps engineers can get caught out when traffic is higher than predicted. And for startups, it's even a harder problem because startups are constantly testing new features to see which is going to do better. So how do you build an MVP that can scale to hundreds of thousands of users? In fact, how can that even be an MVP by definition? So with serverless, you get automatic scaling. This is just a really big win. Building systems traditionally is expensive, right? You need your hardware, you're managing your data centers, you have all of your operational costs, and there's a lot of hidden costs of running applications. And then there's your headcount costs for your DevOps teams that are managing everything. The cloud helps enormously, but you still might be paying for more than you need to. And even virtual instances require patching, maintenance, backups, security, things like that. With serverless, the cost is much more in proportion to the usage. And so it's easy to apportion cost to projects or individual customers. There's also a really huge pressure for engineering talent. And so you want to do a lot with as few people as possible, right? And so small teams are often expected to know everything. So DevOps, security, fintech, you want to have one developer that can do 10 different things, right? And so serverless allows small teams to do more by handling all of the heavy lifting. With serverless, you get services to offload common functionality that lets you focus on features of your software and less on infrastructure management, operational management, things like that. So if you go to aws.amazon.com/free, you can get started with the AWS free tier. A lot of the services that I talked about are free up until a certain point. So it's a really good way to get started with serverless applications. But my favorite part of learning serverless is if you go to serverlessland.com, this is where me and my team post blogs, we post videos, we post learning paths. It's a really great way to get started with serverless applications. And my favorite way to learn how different services work together is with the Serverless Patterns Collection. The Serverless Patterns Collection is a place where you can see how different services interact with each other. And it's basically pre-built SAM templates that you can use to see how different services work together. So basically in one SAM template, you have all the resources you need for that application, and then you just deploy them and get all the resources from CloudFormation. So if you haven't checked out the Serverless Land Patterns Collection, please do so. It's where I go to learn more, and it's where I highly recommend everybody else goes.